Hey, this is Todd Schultz. I wanted to take a few minutes to flip through the PowerPoint deck that came with the textbooks chapter 2. Try to illuminate some of the high points, but again, the chapter's there for you to read, the PowerPoint's there for you to look at. And I just want to elevate things. This is not necessarily kind of from the ground up information. That's what the book is there for, and some of the other materials. But the intent of Chapter 2 is to remind you that system development is often done in a project context. So everything about managing projects and all that theory, if you will, or guidance comes to play in terms of doing um, system analysis and design. And so there's some pretty broad things. They don't just apply to information systems about selecting projects and planning and that. And the book kind of hits with the high points. Okay. Um, Again, the book comes from the point of view of an organization that is doing these projects internally, and that's a good way to think of it. Um, and so there is some notion that of all the things we could do with information systems, what we want is a portfolio or active projects that return good, like a portfolio of stocks that provide a great overall return. And there's this notion of how much does each one worth? Do they work together and provide some diversity? Things like risk. And so, the slide is absolutely true. It's a lot of words. You can almost read it, and there's nothing that is wrong here. It just maybe doesn't illuminate how to go about it. And a lot of what's happening in this chapter, don't fret, where you are in your careers now, you're juniors, students. Um, you might not have the perspective to see some of this, and it might be a while before you apply these kinds of tools. But this is why we're learning. Okay, and so correct. A particular project is looked at as one asset in an entire portfolio. What does it bring? And it comes back to the contributions, what we think we'll get. Go back to that feasibility study concept we talked about last week, and you take it into account with other systems that are going on. For conflict, you don't want to have duplication. You'd like to cover the entire organization's needs and some things like that. So it goes on. And these are all just such true. Almost, hey, you can't. Yeah, we can't do everything. We can't do anything we want. There's a saying, but you can't do everything you want. And so there is that notion. And if two projects have good potential, the one that's sure in a sense of risk is the one that should be selected. So the real thing is getting some tools on how to go about um, doing these things. And so, we've worked with project to document or make a diagram for a plan, but we haven't gone through the doing it yet, and it's going to be this whole term and the rest of your career before you do this. One of the things that makes a project environment different from your typical operation environment are the first and the last. Project has an initiation and a project has a closure. Okay, yeah, ongoing operations have planning, execution, and control. But what makes a project a little bit different is there's some time when we're not doing it, then it gets initiated, then it's active, and then if we're doing it right, then it ends. And so when you look at project management technique that's different from general management technique, some of the differences have to do to that kind of closing end. But there are the steps. Nothing surprising there. Now, when we get it focused into the kinds of projects that come up in information systems, the software development lifecycle or system development lifecycle, it's important to realize that there are some different flavors, suggestions, paradigms about how to go about that. And it doesn't mean anyone's right or anyone's wrong. In fact, we talked about some of the three different ones um, last time. Your book has one, Microsoft Solutions Framework, and then the lifecycle management and that software development course on Microsoft Virtual Academy were all different. And so there are some models out there, guidelines, And again, where you are in your career is more likely you're going to be scooped up in part of a project as opposed to the one leading it. But it helps, or it is content to realize that there are different management kinds of methods, and so we're going to have some diagrams coming up to try to make that clear. So when somebody talks about, and so it's kind of almost like definition, waterfall development, um, it's called waterfall because of the four phases, at least in terms of how the book lays things out. There's something that goes on planning, and there's a sign off, and those specs come back and they go to, then to analysis. It looks like a waterfall. And analysis done, and we have some design specs and some things like that, and that goes into design, or design requirements, that goes into design. Out of design comes up coding specs, testing plans, and that goes into implementation. And so the coding and testing is done, and they get the system. All very nice, pretty diagram, and with the idea that there can be some working back, but that's kind of a minor flow, right? That is, oh, wait a minute, we got to redo the analysis. We discovered something in design. Waterfall development it's kind of the classic traditional, we have a plan and we do it. Plan for a house, build a house. We don't do a lot of cycling and, oh, here's a starter little house, oh, we expand it like that. Okay, so waterfall means kind of very document oriented and forward moving in terms of document and then system. Okay. Parallel development is this idea that maybe we're doing a few things at once. Okay, maybe projects that coordinate with each other, or aspects of a project. Maybe we're outsourcing the purchasing module, we're developing the CRM module in-house, and we're having somebody to choose a package to do the accounting module, and then they're all going to implement together. So nothing here but parallel development means we have separate projects. They integrate at the end, but we break them apart, and so it's kind of independent. If you're involved here, you're probably senior kind of management. If you're involved here, you're probably lower level and more technically oriented. But just don't get caught. Oh, we're doing a parallel development. It's a slightly different plan. Kind of the V model says let's test as we go. And so there is this, notion that as we're moving down, we're getting more focused. And acceptance testing talks about what will work and how things will go. So the analysis leads to this. Here's how we'll know whether we accept it or not. The design says, well, here's a test for the design, an integration test, and a unit test. Then we code, and then we build back up. These are very narrow focus tests. We'll look at some testing plans. Some of this, it's sort of a cart horse thing in this course. That is, boy, it helps to have done some unit testing and integration testing before I look at this, but it helps to look at this before so I can see where these things go. But think of this as low-level testing. Then how do these different components work with each other? How do those combine into a system? And then does it work for the user at the end? And so we'll look at some testing plans, but think of the V model as a testing focus. Start broad, narrow down your scope, and then starting at the narrow end, test the little bits, and then broaden out to that high level. Okay, a V model. Whoops. And somehow I did that. V model. Good. This one's hard to say. This is kind of RAD. It's got rapid application development, iterative development. And the notion is we go through the cycle multiple times, and then we get better versions each time. Maybe we first do a prototype or a sample for somebody to look at, or it's version 1, and then we put, operating systems go like this. Windows 10 is coming out, and so if this was Windows 7, and then they went and then, oh, here's Windows 8, and now they're coming out and they got Windows 10. And so it is a way to maybe not try to do everything all at once like the waterfall, but do things in stages. It helps sometimes when you have to time box, get things done by a certain date. So you say, okay, here's the features we can get here, and then hope to get the follow-on. But the idea is, a version 1, a version 2, a version 3, and the Microsoft Solutions Framework, if you remember that from last week, kind of had that cycle. But iterative development, and that's probably the most common broadly speaking, approach that folks apply out there. It's nice to have something tangible, even if it's not complete in terms of all features, but it is complete in the sense that what you have works and hangs together. And so that's RAD, or Rapid Application Development. And sort of think of a prototyping version of RAD as we do an analysis cycle and have a model that people can do. This is kind of like what it's going to do, a mock-up, if you will. And so you simulate how the system is going to work and use that to hone the design. So there's this cycle here, and you can think of these as releases of the prototype, and then, okay, great, we want to go, and then it's the implementation. Go back in the old, car design or something. You might do this. Oh, here's the clay model, or now here's the computer model, and here's the air tests, the wind tunnel tests, and some things like that. And here's this prototype that we're showing off at the trade shows, but we're going to keep this and make it a production model. Okay, and so that takes kind of a sophisticated audience to understand that a prototype's not really a working system. But managed right, that is just another way to go, and we are now at just the very high level of ways to go away. And throwaway prototyping, that's one of the things, is realize sometimes these prototypes are there to toss. I had a client one time, thought the prototype was the real system, and I thought it was a way to get the design requirements. I didn't manage that well, but I should have managed the expectations a little bit better, so they realized that, oh no, you shouldn't have entered 10,000 records. I wanted you to enter 10, so you could see how it worked, because I'm going to throw that away and then design the new system. Well, and here's a picture of it. And right, so we have the design. And this helps us define the design, and then we implement. Okay, so we're not leveraging off the prototype, but we're using the prototype to help get the design specs. Okay, so, and it's a different notion. Let's see, Agile. Agile really could be in any of these methods, but it's most closely associated with the iterative method. But Agile development, kind of favors interaction over documentation, and it's just this approach that says let's build in small increments and get a lot of feedback. And it's a management style and a development style that can be very powerful. It does take a discipline to kind of keep progress going, and there was built in this notion of what's called extreme programming, customer satisfaction. So you get your techies out there with the customers, and teamwork. Maybe two people, one code. So think of developing a spreadsheet, but you always had somebody else there, kind of looking over your shoulder. That's the notion of Agile development. And at the level we're at, I can't really do much till we get some examples to, okay, make that a little bit clear. And so, it almost tries to integrate the system with these steps. And really what I would show if I was going to draw the diagram is little updates to the system in very short cycles. And, the notion of extreme programming or agile is over in the next sprint, they call it. In the next week or 2 weeks, what are the most value-added things we can add to the system? So let's time box those, figure out which of those we can actually get done in the team, push them in, and then in a week or two, we ask the same question. Well, are those working? If there's something keeping us from making progress, what it is, but if there isn't, what are the most value-added things that are missing or buggy in this, and let's sort those over. So it's exciting, takes a very adept kind of management. Most of the management theory and instruction and guidance you get stands off a little bit. Here's the specs, here's the project plan, and then there's some time and the users look at it and it comes back. This one is kind of hand in glove with the system and the users, and it's exciting, but it's tiring and takes a lot of attention, but it's probably the most effective if you do it right. In terms of getting something new going, if you have an energetic and interested user and an energetic and an enthusiastic developing team. The user, ignorant and apathetic, right? I don't know, I don't care, and these guys just want to get paid, or they're not sure what to do. It can be a disaster. A more formal, structured method might be much better in that case, to give people time to think and react and go on. And so, here's a nice chart might keep it handy, in a discussion question sometime. Oh yeah, we got some people who are unfamiliar with the technology, and it's a complex kind of thing. Would agile development be a good idea? No, not really. Agile is good when, okay, yeah, I understand how to make this happen. I don't need to do research on how to build that database or that interface. On the technology side, the users know what. It's pretty simple. I can tell you. The users can tell you what's going on. So, here's kind of a chart that helps you decide which one is good in each, and that's in the author's opinion, and we'll accept it. But you almost have to go around and do 2 or 3 projects before this is anything else than maybe suggested guidance. Okay. Good. So they have benefits and advantages and disadvantages of each. All we can do is take that as some guidance. All right. I wish I'm using their PowerPoint. I wish they wouldn't have the animated slides. Great. Yeah. So those were the column headings, and yeah, just realize that it matters. If the system's complex, how reliable it needs to be, what the time schedules are, and like that. All right. The book goes through some guidance on how to estimate project time. Okay, how long will this take? And it's not bad guidance, but like I said, until you've done it or been in a project, it's really hard. One thing we can take to the bank, and so we will, in a number of exercises, use these percentages, right? Planning, analysis, design, implementation. So if I told you that there's a 100-day project, that we're going to go ahead and try to figure out how much should we spend in each of these. Well, 100 days, 15 days ought to be spent planning, 20 days doing analysis, 35 design, 30 implementation. You can use those percentages, and that's a good guideline. So, I don't know what it'll take. Well, if you know your project duration, you can work back. If you have a time box is it's going to need to be done by this time, then divide the time between now and then, or between whenever you're going to start and then, in these percentages. That's something you can go on. The project estimation, like how long will it take to code things? We'll get some background in that, but just go. And so they were, kind of showing that, person months, what the effort is that's broken down by those, and you can think of it as time as well. All right. You can look at the function of point approach, realize that there's something called the function of point approach, and it gets into the number of modules and subroutines and objects, and it's for a much more mature, and I don't want to call you immature, a much more mature analyst base than us. And it's nice if the projects are all in kind of one common domain. Where I've used a function point approach is sometimes in Excel spreadsheets. How many formulas do you have? How many formulas that refer to multiple pages? How many times are formulas copied? And you can get into sort of a rating or a scale for project complexity. What you ought to realize about a function point approach is, it helps you estimate project complexity. It is, that's about where we ought to leave it for now. This is System Analysis Design 101. Tasks. Okay, identifying tasks is important. So now they're kind of going into the project, the WBS, work breakdown structure. Okay, and we've been dealing with tasks or phases with subtasks and that. And so realize that project task has tons of information associated with it. Start dates might be assigned, maybe they're derived from something else, but these are a lot of the kinds of things that go along with a task. Okay, and so and I don't think looking at the list anything that says, well, why did they ever decide what deliverables are? Okay, current has that done. Priority, so these are things, and in Microsoft Project you can add these to tasks, and we'll see some of that. So it's easy to say, oh yeah, identify tasks is an important thing for project planning. The hard thing is when it's up to you, well, what tasks? Who's going to do them? What are the deliverables? That's where project management comes in, and that's where, this book sort of and this course gets you going on it. But it's like the difference between reading a cookbook and making a supper. When you're home late from work and the kids are hungry, that's a whole takes a whole different meaning. But the idea is tasks are those little units of work that combined make up the project. Okay, and based on based on the work breakdown structure. So work breakdown structure is how the individual tasks combine to bigger tasks, combine to bigger, right? So design phase is really a database thing, a regex handling document, develop OLAP, whatever heck that is, right? Object. Anyway, it's sharing objects. I forget what it is, what the acronym stands for. But develop database. Oh, if we had the stage database design, the suspense database design, then we'll have the database design document, and that's one piece of doing the design phase, right? So it's almost like a project plan, but it's called a work breakdown structure because of this outline kind of thing, right? And so we know that these three combine to this, and this one and maybe some others combine to that, and it really helps us to go. And we know about dependencies. This is saying I need 1.1.1 and 1.1.2 before I can move on. So work breakdown structure, the principle of what it is, I hope is real clear. Now, exactly what tasks I need to do to get a project done, it's a little bit harder, okay? But you should be able to look at this and say, yeah, I understand what this is telling me. It's kind of like that project plan. And then there's putting some dates to it all. And this looks a lot like Microsoft Project, right? And we can get all these facts. And so this is some bookkeeping things, and sometimes the dates are derived from when other things are done. Maybe we just put them in because we needed them done, but realize that the work plan takes the work breakdown structure, which is a list of tasks, and puts dates and times, and then we have an ongoing, how do we stand? These are all still being worked on. Oh my God, no, they should have been done a year and a half ago. Well, it's an older book, right? But that's when we talk about a project work plan. That's what it looks like. Getting there is what the course is about, and what the whole curriculum is about, and your career is about. Okay, staffing, we are even further removed. Then we're not going to get to boss any people around. A couple of things to keep in mind. First, keep in mind we talked last week about roles, and I especially like the Microsoft Solutions Framework role model to remind us that we need a program manager, somebody managing project time and thing, and a product manager, customer facing, somebody to do the development work, somebody to do the testing work, somebody to do the releasing work, and somebody to do the user experience kind of work. And I think they had architect in there, right? So part of staffing is getting the right kinds of talents, or making sure folks understand what their role is in the project. There's a lot of project management theory, and we'll get into some of it as we get deeper in, is adding staff may actually slow you down if you started a project. There's just this communications thing that needs to go on, and you add more people, then there's more communications lines, and so just realize that adding staff may just not be the best. Yeah. Sorry for the delay there, just felt like I was going to answer that. And so we're going through project stuff and blah, 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 blah. Project work plan. I was getting through staffing in the Microsoft, the different roles, adding people, and gosh, there's tons of theory on teams, and we'll touch on some of it. I'm not ready to say more about staffing at this point till you get there. Okay. This is a hierarchical reporting structure. I've given you a project management chapter reading to do as well when it talks about matrix organizations, where there's little cross-functional kinds of things, but you should be familiar with what an org chart looks like, and that in principle is how you might organize. I guess the important thing to realize is functional leads are more about business analysis, technical leads are more about the technology. Okay, and so developers and UX people here. It's kind of a way to program manager, maybe product manager there. So you can superimpose the Microsoft team model on your org structure. Okay, and good. Yeah, functional lead. Projects ought to have a charter. What's the objectives? You will have some chartering exercises come up. Staffing plan. Well, what else would a staffing plan be? Right? It's about staff. So some unnecessary slides. Gosh, motivating people. Kind of got nothing to add here. Maybe we'll get to some things. They say, I guess, this. It's like you have that, and that I'm just going to leave it. The motivation can come up. There are some good ways to help manage conflict, though, in some structure, and we'll see them. These are just here bromides and that, but this idea of norming and getting teams to maybe develop their own internal structure and mediation is a good way to handle conflict. And that ahead of time scheduling, and as the manager, sticking with it and making clear that you've looked at the deliverables and they're important, and how they go will do a lot to eliminate the conflict. But we'll talk about some going forward, and maybe some things you can do to manage conflict if it happens and people disagree. Gosh, that is so situation dependent. I don't know that I can do anything. And there's a set of tools. Visio is maybe a lower case tool. It lets us do the diagrams. And in Visio 2010, and maybe I hope in the next release, they'll take back, it used to be more integrated with the system. So if you had a database model, you could push out and make a database from it. If you had an object diagram, you could go make the code from that. So Visio is an example of case we might be using a visual paradigm to a little stronger version of this computer-aided software engineering. Keep track of our requirements, keep track of our documentation when something's signed off. Try to make a template for the system. That's what CASE does. The only example I can give you is you've dealt with it in some light ways with the work we've done so far with Visio. And within the system, and I tried on my specs and my tech prac things. It's important you name files the right way if I'm going to store them somewhere. And lots of kind of documentation can be online on how things are done, how the program ought to be developed. There's this notion while we're doing a project, keeping the documentation going and not doing it after the fact. And so, this is how you ought to do it by the book. A lot of don't. Okay, and boy, this is fundamental. And we had it in MINF 3650, but you have the time, scope, and cost. Right. Those are the three things that need to get traded off. And if you're going to try to push one, then something else has to give. Right. If somebody says, "Oh yeah, I know we're doing this, but we need to get it done quicker," then maybe we get rid of some of the functions, or maybe we get more money, but you can't push one without affecting one of the others. So when you're in a management dilemma and trying to manage the conflict, if it's one of these, if you need to take on one, then think about what you're giving on the other, and vice versa. If you need to demand new features, then we've got an expanded budget, but don't worry, the new features don't need to be done till this time. If you can't do that, then you really aren't doing this, right? And so sometimes your back's against the wall, but that's why management and administration is one of those higher level tasks. You figure out some ways to do it. But a structural thing is, what am I giving and what am I getting, and working it that way. And there's, looks a lot like project right there. Refining estimates. Yeah. And yeah, and this is, if you keep track of data, I think what it's showing is how did we do against our estimate. And it's important if you get into this project kind of thing, and we won't, now we're not talking, earlier I said I can't really make this necessarily more relevant than just reading it until you've done a project or two. Until you've done 5 or 6 projects, it's hard to know, oh, okay, well, we went 400% over on cost, okay? Um, and, but we hit the project plan at the right. It's kind of, how do I refine estimates? There is this question. Suppose I had, a project with 2 phases, and they each took 1 day. Very simple project. So, and they go end to end, so it's a two-day project. Suppose I get to the end of the first day, and I'm only 1/3 done with that first task. Well, I've blown it, right? I missed, I made a mistake, and I've already eaten 1 day, half the project time. Comes the thing, what's your estimate now? Finished 1 day, you're 1/3 done with the first task, and there's a whole other task. What's your estimate of when you're going to finish now? Somebody might say, oh, we're going to finish tomorrow anyway. Somehow we're going to do the 2/3 of today that didn't get done, and the whole day tomorrow, and we'll get it all done in 1 day. Okay, kind of optimistic. Somebody else might say, oh gosh, it's going to take 1 and 2/3 days more. We finished 1/3, we still have 2/3 of 1 day in the other. But that doesn't recognize the fact that what you thought was going to take a day now looks like it's going to take 2 or 3 days. Somebody might say, man, I'm only 1/3 of the day with one. It's going to take me 6 days to do this because all my estimates must have been wrong. So there are some rules of thumb for somewhere in between there. But boy, if you ever get behind on something, you get one ask of the customer to get it right. And so, think about what you're going to need to get it done and can deliver and make it so. But there's a whole world of managing that, re-estimating your time, and this is scope creep is new features get added. Oh yes, I can do that. I have scope creep all the time in my job, and because I really don't have any way to necessarily manage this, my only thing is no. But if you're managing a project, it's critical, and you want to please the customer, but say, that wasn't something we agreed to, and try to keep it from getting to be more and more. And while you're at it, do this. Consider while you're at it. That's 3 or 4, so 4 or 5 words, depending on how you have the contraction. They can get very expensive, and so that's As a manager, when you're doing it, that's yours. I mentioned time boxing, and time boxing is, I've got a fixed deadline. What can I get done? As opposed to, oh, here's what I need to get done. When will I get there? So it's another version of that trade-off, right? If you have a fixed amount of time, then you can work with what we can get done in budget, and you try to eliminate the things that aren't the most, only do the things that are most critical. But the term time boxing is, I have a deadline, what can I get done, as opposed to, here's what I need to do, when will I finish? And there's 2 different ways. And sometimes you get managed one way, sometimes you manage the other. Yep, and I just said all that, but I didn't take a 6-step program to do it. Okay, and we'll practice with some of that and some of the exercises. Oh man, risk. We'll come back to risk. Risk is this idea that something might go wrong, and so we'll have some very structured exercises on how to identify where risks might occur, what we might do to mitigate those risks, and then see what we can do to help. All the way from customers not liking the product to we don't know how to get there. Saying that 3 bullet points. I mean, there's whole books. You can be a project management risk specialist as a career, and so it's way more than 3 bullets. All I have to say is we'll put off before we have some deeper exercises on that. Critically important, but I've got to put you in an exercise before we can do some things. All right, so again, a lot of talk and top level. It's starting to build your verbology, if you will, your glossary is better, your terms and what they mean, and get used to seeing them because this is the language of management and administration, and projects are the wave of now and the wave of the future. So I hope this illumination helped. Chapter 2, read the book, watch the PowerPoint, um, and it's setting the stage for where we're going to go later on. All right, take care. Till next time. Bye-bye.